All right, so let's just dive in. So the first thing to do is on the left is, that's the easier part typically. Just find me what the acid and base is. This is HClO. You think that's an acid or a base? Probably an acid. What's the dead giveaway? Starts with an H. Oh, hey, acid, acid. That would mean these are bases, right? Now, it can be either, yep. So now, HClO comes over here. We have HSO4 and ClO minus. So this is an acid because it gave what away? Tell your partner. A proton or H. All right. This is what then if it goes the other direction? That's the conjugate base, because this direction, that accepts the base. So we have our conjugate base, which would leave this as the conjugate acid, which makes sense because if the arrow's reversed, where does that H go? It's donated away, and that's what acids do. Okay, so as long as, I don't know, some kids way overthink these. If you go and identify the acid and the base on the left, usually the conjugate acid and conjugate base are pretty easy. Go ahead.
So whichever one was the acid, and then that one then is the base.
The conjugate base. Yep, they just switch. Because in one step it gave it away, which means the other step it's taking it. Okay, so if this is my acid, then this must be my what? Conjugate base. Now I know they're in a different order, and that's fine. That doesn't, they don't have to write one first or the other. But if NO3 minus were to go this direction, what would it be doing? It would gain a proton, and that's what bases do, which means this is my conjugate acid, because if it went this direction, it would lose an H or donate an H, and that's what acids do. Okay, so here we have H2S. This is just HS. Here we have H3O plus. So the HS, which one is that going to be? My conjugate base. Base. Because it only has one H here. Over here it has two, which means this accepts an H. And then H3O plus must be my conjugate acid. H3O plus will never be a conjugate base. Yay, host of stuff. All right. How many Bensons are in HOSA? All of them? Well, you got one. I didn't read it. I just saw your names on it. Other way around. Not that it really matters. My hands are dry. You grab that one. There's one more underneath it. What the? You get two for fun. Okay. Thumbs up. Are we okay? Thumbs up. Okay. Tim, you're good? All right. I'm moving on. Lots of chatter today. All right. We've talked about strong, weak electrolytes before, right?
Yeah.
We've memorized strong acids and bases, but just make sure you should have. Make sure what you should do is before the AP test, have a gym kit party at your houses and do all these memorizing things. Oh crap. I'll let you hack into my system. I'll start it. You text me, I'll start it. Okay, here we go. Acids, strong acids, I should say, completely dissociate in water, meaning they fall completely apart. So HCl goes 100% to H plus and Cl minus. It's really strong. And strong is defined by how well it makes the substance conduct electricity. That's why it's called a strong electrolyte, is because putting this into water causes the amount of charges in the solution to skyrocket, which means it becomes very, very conductive. This is going to be a really important thing right here in the next bullet. Their conjugate bases have negligible basicity, meaning they resist protonation. Okay, so what this means, it's new words. It means that if you have water and you add NaCl, the Na plus goes in, the Cl minus goes in, but it stays neutral. Na plus and Cl minus have no effect on the pH of the solution because both Na plus and Cl minus come from strong acids and strong bases, which means acid-wise, it resists protonation. It resists sticking to an H. Weak acids only dissociate partially in water. So like if I have acetic acid, which is HC2H3O2, we have just a tiny bit of H plus and C2H3O2 minus, like almost none of it dissociates. Now, this is interesting. This is something a lot of kids just never really get for some reason. Their conjugate bases are weak bases. Okay, now let me explain what that means. I'm kind of busy, Matt. Okay, that's fine. Okay, so this is what this means. If I have this beaker of water and it's just chilling and it's completely neutral, please try and follow this logic. And I'm going to add this time some sodium acetate. Now, we should remember from chapter 4 that this sodium acetate is a very strong electrolyte, which means it completely dissociates in water. Now, what I'm about to say people don't like is acetic acid, an acid you memorize as being strong. No, this is a weak acid. Okay, so we got to think about the secondary part here. Sodium acetate is added to water. Yep. So what happens now is the acetate ion finds a hydrogen ion that awkward moment when your battery dies and you still talk. All right, to become this acid again. So what happens in this solution to the concentration of H plus? It goes down, which carbon means it's basic. So I was able to make a basic solution even though I didn't add a base. I added the conjugate base of a weak acid. Who's with me? We're going to do this a lot. Kids, like years and years, we talk about these solutions and buffer solutions specifically, and we add a salt, and they're like, oh, this isn't even an acid problem. He just added a salt. Well, you have to care about the the anion and the cation of what you're adding, because they may affect each acid or a base. I don't know what's wrong with my mic, but oh well. Okay, so far sort of okay. Okay. So here is some things that are an example. These, well, hold on. If you put these into water, they will not affect the pH. because they will not cling to an H. If you put these things into water, they will affect the pH because they're going to remove free hydronium and tie it to the acid. Okay, same thing. I guess it kind of switches right here, but same thing here. If I add these things to water, it's not going to affect the pH in a basic way because they are strong. Okay, here we go. Oh, I've done that before, and that, and that, and that. Wow, I feel like I've used the same slides for 10 years. Wonder why I would feel that way. Oh, all right. In the notes, did we talk about Ka yet? Ka and Kb? All right, we'll get there. There's just an example right here. Holy smokes. Okay. Substances with negligible acidity do not dissociate in water. Their conjugate bases are exceedingly strong. It's just what I said about the bottom half of that picture. Yeah. Daylight savings Monday disease right now. Yes, Corbin.
Does it matter how weak or not weak the weak acids or bases are, but do we still have to account for the fact that they will take part of the H or the OH?
Not sure I 100% understood what you just asked.
So when you add you added the acetate to the water, you had to take into account that it took some of the H's away.
Right.
But say you added one that was like weaker than that, like sulfate, would it be the same thing? It would just be slightly less basic than the acetate?
Yes. That one's a tricky one because that takes 2 H's, but whatever. But yeah, as a general rule. All right. So in any acid-base reaction, the equilibrium will favor the reaction that moves the proton to the stronger base. Bases want to accept protons. So the equilibrium will shift to the place where the thing that wants the proton the most is favored. So in this example, we have H2O, just the bottom line, is a much stronger base than Cl minus. Now, to put that into English, H2O is better at staying together than HCl. So when you put HCl in water, the Cl minus stays completely dissociated and the water grabs the extra H. Okay, this isn't like on the test. It's just kind of trying to explain what we're just talking about. All right, now it's K is significantly greater than 1 is what that's trying to tell you. And it just means if that is the case, then the products are absolutely dominant, right? Okay, oh, in case you needed them again, at the top, those are the strong acids. I'm sure you have them memorized, right? No one does? Who knew that HCl was a strong acid? Okay, you should have, because the last 20 minutes I've said it 10 times.
That's our favorite acid. So
That's the one that's the cheapest for me to buy. So that's the one we use the most. Although I need to start using sulfuric. I have a whole gallon of it I haven't used in a long time. Great. That's HI. The last one is HI, not HF. That's a very important question Seth just asked right there.
yeah, HF, isn't that like the very big one?
Yeah. Oh, it's locked. Oh no. I can play your game. bring it. Watch this. Boom, done for life. Why did it disappear?
You click the button. Wait, it's HF?
No.
Oh, I know what the problem is. I think I know what the problem is.
Problem is just big.
Well, it's a tiny bit better, but okay, next. And just saying what I just talked about. So acetate, meaning this. Oh, I'm in white tool. What a disaster. Is a stronger base. Meaning acetate wants that H pretty desperately. So it is a stronger base than water. So this time the reactants are favored. Sound pretty good. All right. Let's get to some math, don't you think? All right. As we have seen, water is amphoteric. What does that even mean?
Good question.
It can either be an acid or a base. It can act as both. We just saw it in the last two slides, pretty much. All right, in pure water, a few molecules act as bases and a few act as acid. This is referred to as autoionization. This is the long way to write it. Another way to write it is OH. I can't, that's unacceptable. That is, oh my laws. Dissociates into H plus OH minus. It might not look like the same reaction, but that's the same reaction. When two water molecules collide to form H3O plus and OH minus, we call that autoionization. When one falls apart to form H plus and OH minus, we also call that autoionization. Now, here we have equilibrium, where the same amount of stuff here and the same amount of stuff here are at equilibrium. So if your acid is equal to your base, what would we call that? Neutral. Water is neutral because the concentration of H plus and OH minus are the same. And it should make sense. Think about it. For this process to happen, it has to break apart, right? Well, it broke into equal halves of H plus and OH minus. So in just pure water, it's always neutral because if one breaks, it breaks into both parts. You with me? Okay. Yes. Just kidding.
Okay, I love these.
Yeah, there's plenty more coming. All right, the equilibrium expression for this process is Kc equals, I wouldn't stress about writing much down here at all, but Kc is equal to, and I'm going to simplify it to H plus and OH minus. And how come I don't have a denominator? Tell your partner. Because water's a liquid. Good. All right. Now, when it's at equilibrium, these are the same numbers. And their product is always equal to this. Which means whoops, that's a 7, not a bracket. How much will this erase? What a fun game. Oh, good. Okay, now look right here. I know this is kind of confusing, but just kind of stick with me. This special equilibrium constant is referred to as the ion product constant for water, or Kw. All right, now it's Kc, but since it's just water, we change it to Kw. It's really nice because it's always the same value. The answer is always the same. It is 1 times 10 to the negative 14, always. Now, at neutral, my A and my B are equal, correct? Can someone tell me the pH of a neutral solution? 7. Look right there. The only way these can be equal is if they both have a concentration of 1 times 10 to the negative 7. This number right here defines the pH. pH, and we're going to learn this more in a second, but it's equal to the negative log of H plus. Logs are just exponent finders. Negative means it becomes positive, so that's why that turned into a 7. Okay, now we can use KW. It's always a constant value. So if I know that 1 times 10 to the negative 14 is equal to A and B, if I know A or B, I'm ready to roll. You kind of with me? It'll all come together in a minute, I hope. All right, so I'm not going to worry about that yet. So here we go. pH is defined as the negative base 10 logarithm of the hydronium ion concentration. This is stuff you've done in math 1010 or whatever you're in now. Math, what's it called? 4, 2, 3, 3. All right. You've probably done logs in the last 2 months. Usually it's the end of the class. So if you have A, maybe not, but B, you've had it. All we have to do in our class is push the button that says log on it. Okay. You don't have to do a lot of fancy stuff. You'd push the negative button, technically, log, and then you'd type the number and then hit equal, and it would give you the answer. So don't have a heart attack about what logs are. All right, now, what is this? What's under this thing? Sweet, I have no idea what that's there for.
Just a box.
Yeah, at some point in time, I had it up there. All right, so, no, I have no idea what I'm doing right now. What are you doing? You're driving me nuts. Poor Isaac. All he wants to do is learn.
That is not true in that way.
All he wants to do is party.
All he wants to do is
All you
sleep.
do is like strangle me with a
So yeah, he called me a gringo.
All right, my friends. Okay, it's calculator time. There's a bunch back here that no one ever put away.
Corbin, you grab me one. Hey.
You're a wizard.
All right, my friends. Are we ready? All right, my lab partner back here says it is 2.58. Who agrees? You okay with that? Okay, could you tell me then what the OH minus concentration is equal to? 1 times 10 to the negative 14.
Wonder why.
All right, who has that answer? It won't be 5.9. It might be times 10 to the something.
It's 3.876 times 10 to the negative
Negative what?
96. Negative 15.
That can't be right.
Wait, what? How did that work?
Wait. Wait, no, hang on. I bull tracked it. Hang on.
Was it 3.8?
It's probably the negative 11.
The negative. Wait, hang on. Wait, hang on. What?
We'll find out.
Oh, yeah.
Okay, we better do it together, right? Okay. Was it negative 11, Isaac? The exponent.
I'm an idiot, everyone. It's the negative 8.
Whoops. Can't be.
Third time's the charm.
That's a possibility. That is a possibility. Okay, everyone look at the screen. Quit saying I don't know how to do it and start learning how to do it. We got this. We learned a minute ago, and look, I did not expect you all to pull this off like perfect, so don't panic. We learned a second ago, I'll come back, that Kw, which was 1 times 10 to the negative 14, was equal to the concentration of the acid. Welcome back. Whoa.
Human hall pass.
Okay,
He was down in the counseling office.
Okay.
We were going over some things.
sounds good.
Thank you.
Yep. All right. So we have the H plus and we have the minus, right? You with me? All right. So we had H plus. Now I need to know the OH minus concentration. So I end up with, I know this now. I'll just plug it in. It's 1 times 10 to the negative 14 over, I gave you this value, 2.6 times 10 to the negative third. Now you have to type this in all in parentheses, or you get the right number but the wrong exponent. So Isaac had the right value, just the wrong exponent. That's extremely common, and we can learn from it. Here is, by the way, how I knew he was wrong. The two answers, their exponents, not the answers, but the concentrations, their exponents have to add to either negative 13, 14, or 15. They have to. If they don't, it is 100% incorrect. Okay. When it's just pure water, it's just a nice, beautiful 14, and it's a 1 times 10. But when we start getting numbers, so I have a -3 plus a -12, that's a -15. That is a reasonable answer. But -18, I knew it couldn't be right because that would have added a -21. So when you are finding H plus or OH minus, your two of them, their exponents have to be close to -14.
This was the acidity of the water after we put the acid base in.
So what would the pH be? We said it was 2.58. So is this an acid or a base? It's an acid. Who's with me so far? I know it's like, what are you talking about? It's kind of all a mess that eventually comes together at the end. All right, here's the question for you. If my pH is equal to 11.62, okay, it is a base. Here's what I want to know. I want to know the H plus concentration. And I want to know the OH minus concentration. So this is a little bit different. How do we figure this out? What's that? Yeah, most people have no idea. Yeah, that's what I would do. Yes, Seth.
What makes it a base center?
Whether it's above 7, if it's above 7, it's a base. If the number is below 7, it's an acid. Yep. All right, let's just work on this together since very few have any idea what to do. We know math-wise, pH is equal to the negative log of H plus, right? So we have to algebra this thing to find out what this answer is, because I want to know the concentration of H plus. All right. So a lot of people want to divide by log because they think that's the reverse, but that is incorrect. We need to take the inverse log, which on your calculator, you hit second and then log, and you'll notice it just puts a 10 raised to the whatever, right? So the inverse log is just 10 raised to. So it's 10 raised to the negative pH. Okay, 2.39 times 10 to the negative 12. Anyone agree with that? Okay, good. Then how would I find OH minus? Good. 1 times 10 to the negative 14 over 2.39 times 10 to the negative 12. It's probably 0.0 something. That's okay. That's we all right with those? Okay, I'm going to teach you something to do this a tiny bit faster if you feel like it. I'm going to go back to this one. We found out the pH of this first one was 2.58, right? So the pH equals 2.58. And I wanted to know the OH minus concentration, right? And then do what? No, to the log. Okay, so what we have here, we have pH, but we can certainly also have what we call pOH. And pH plus pOH is equal to 14. If this part doesn't make sense, just do it how you have been doing it.
Wait, what does the P stand for?
P stands for negative log. P means power, which means exponent, which means I got to use the log function.
So it's kind of concentration, but not really.
No, it's a measure of the power of the exponent that the concentration is. All right. So if I take 14 and subtract 2.58, I get 11.42. Is that right? Right? My math in my head. Okay, what would I do with this number now? I take 10, raise it to the negative 11.42, and you should get, if math is true, you should get this same. I don't, in all my career, I don't know that I've held this down and tried to make a line at the same time. That one worked. Yep. Okay. This process is called using the power of the hydroxide versus the power of the hydronium, or pOH. Should be the same way. I don't know if you love that, but coming over here, it's really helpful if all you have is the pH equals 11.62 and you need the H plus and the OH minus. Okay, well, this is 11.62. then the OH must be 2.38, correct? POH. So now you just take the negative, or sorry, 10 raised to the negative 11.62, and that tells you that value. Then 10 raised to the negative 2.38, and it gives you that value. They all tie together. That doesn't mean they're easy, but it means they're like, each piece does rely on and can get you to the other one. Okay, the question was asked, what does P really mean? And that is this slide. Don't write any of this down. But in science, we have lots of these. We have pH, POH, pKa, pKb, pKw, pKc, pK, though SP, and I'm missing one. I don't remember, but it doesn't matter. P in science means we're finding the exponent that 10 is raised to give me that number. And to do that, we have a function for that, and that's what we call the logarithm. A logarithm is simply an exponent finder. That's all. You're like, I wonder what that exponent is. Well, the function to do that is to push log on your calculator. Now, they're all log 10 in science. In math class, they'll mess with you sometimes. And it like blows your mind. You're like, log base 3, I don't know what to do. No, it just means what exponent is 3 raised to now that gives you your answer. You don't have to overthink it. So all these things are the same idea. And we put a negative in front of all of them. And that's just so that they are positive answers in the end. Because it's finding these concentrations and all their exponents are negative. Hi. But we want our answers to be a positive value. And now they're partying somewhere. My whole ceiling is shaking. Okay. Lots of talking today about stuff. All right. Ooh, all the answers. Oh no. Okay, so we got 3 questions here. What is the pH of a solution with a H plus concentration of 0.0045? And if you're like me back in the day, I'm like, I don't know. He just did 1 times 10 to the something. Well, this is also known as 4.5 times 10 to the negative 4, if you like typing it that way better. All right, how we doing? So 0.0045, we type that in and we get the pH is equal to what? What? 3.3. All right, conjugate base of HCl. Cl minus. What do we know about Cl minus? It does not grab H and go the other direction ever. So it is a conjugate base of a strong acid, which means it does not affect the pH. Now the H plus sure did. Okay, number 3, what is the H plus concentration of a solution with a pH of 10.25? So we take the inverse log, which is 10 raised to the negative 10.25, and we end up with some number. Okay, seems pretty good to me. Could that be the test? No. This kid, oh, he throws 163 and he thinks he owns the world. That was a sick throw. Timmy, what kind of attitude is that? Honesty. Okay, fine. All right, that wasn't too bad. All right, just to save you guys some time, because it is very common on the AP test that their concentrations are just 1 times 10 to the negative something. If you understand logs, these are pretty easy. We're finding the negative exponent 10 is raised to when we find pH. So if it's just 1 times 10 to something, the pH is the positive something. If this is just 1 times 10 to the something, OH minus is also 1 times 10 to the negative something. Anyone know what it is? Negative 9, because these two exponents have to add to negative 14. Since this number is less than 7, then this has to be an acid. You with me? Okay, if this, what? I'm going again. If this is 1 times 10 to the negative 10, so if this is just a 1, then this is just a 1 times 10 to a negative value. Negative 4, good, because these two numbers have to add to negative 14. If this is a negative 4, the pH is the positive of that negative, so that's a 4. All right, and it is an acid. If this is a 7, what do I know about this exponent over here? Negative 7. If it's, look, if it's a whole number, meaning it's not a decimal, then this is just 1 times 10 to whatever that negative value is. If this is a negative 7, what's this? Negative 7, and this would be neutral. Now here I would have to use a calculator. But, if it's just ones, life's really simple. Okay. All right, we'll just call it good right there for today. You're welcome.